So hey everyone, welcome back to the channel. This is Abhishek on the other side. If you are new to our channel, do subscribe to the channel and press the bell icon in order to get the latest notification first. So without much further ado, let's start our today's video. Today we are going to solve a hard level problem from Leetcode. The name of the problem is merged k sorted list. So the problem states that you are given an array of k linked lists. Each linked list is sorted in ascending order. Merge all the linked lists into one sorted linked list and return it. So what this question is basically saying that we are given k, the k number of sorted linked lists, right? So let's say that so let's say the value of k is 2. Okay, so we are given two sorted linked lists. Let's say the linked lists are 1, 3, 4, and there is another linked list which contains element 2 and 3, right? Now what we need to do, we need to merge these two sorted linked lists in a sorted fashion. So what do you mean by that? We need to return after merging, we need to return it in a sorted way. So after merging, the sorted linked list would look like this. That is, it will contain element 1, 2, 3, 3, and 4, right? After merging and sorting, this would be our result. So you can see over here that it is written that the list, if we over here, the value of k is 2, right? And it contains two linked lists. So one is 1, 3, 1, 4, and 5. Sorry, the value of k is 3, right, over here, because there are three linked lists. So one list contains 1 to 4 and 5, another one 1, 3, 4, and another one 2 and 6. So after sorting and merging, this is our final output, right? So let's see for more example. So let me just delete this out. Yep. Now if we have an empty now if you have an empty linked list, then what we would do? We would also return an empty one. And if we have a linked list where the value of k is 1, right? In our previous case, the value of k is 0, and hence there is no linked list. But here the value of k is 1, but there is no element present in this linked list, right? And hence it is also giving me a null, right? Or an empty array, empty linked list, you can say. Sorry. So now let's understand the algorithm for this problem. So let's say that the value of k um, is 2, okay, and the elements the k contains, so there will be two linked lists, right? So let's say that one of the linked lists contains 1, 4, 5, okay. Now let's say there is another linked list which contains somewhat like 2, 3, right, and let's say 6. Now Now, what will be our final result? Our final result will be 1, 2, 3, 4, 5, and 6, right? So the brute force approach we can apply to this. So the brute force approach we can apply to do this problem is that we can at first merge these two linked lists. So after merging, our linked list will look like this. That is, it will contain 1, 4, 5, 2, 3, and 6, right? Now this is what our linked list would look like after merging only, okay. And after merging, we can then perform the sorting operation, and then this would be our final result. But to do this, we require a time complexity of somewhat, if we consider the number of elements If we compare sum of the number of elements of this two of this linked list as well as this linked list to be somewhat like n, okay, then our time complexity will be n log n, right? Because that's what we take for sorting. Now we can actually reduce this time complexity. So let's see the optimal solution now. Now let's see the optimal solution. So in the optimal solution, let's say that we have a let's say our value of k is 3, okay, and there is elements like 1, 2, 4 and 6, right? Now let's say there is another list which contains like 1, 2, 3 and 5, okay, and there is another linked list which contains only one element. Let's say 2 with 3, okay. So these are the three linked lists which this so these are the three linked lists, right? Now since this now in the question it is given that the linked lists are sorted, right? So this is our one of the advantage. So what we'll be doing here, we'll be using the concept of min heap. Yes. Now what is this min heap, you may ask, right? Now let's say that we have an array, okay. So let's say that we have an array 1, 3, 5 and 4, right? Now the task of min heap is that it is gonna give me the minimum value present in this array. Yeah. So in min heap what happens? The root of the heap, right, is will be the minimum, will give me the minimum value for this array. So let's say that there is an element 2, right? So if you just at first we need to, what you need to do, we need to actually build the heap, right? So we can build the heap like this way. So it will be 1, 2, 5 and this is 4, right? So after building the heap we need to heapify this, right? So after heapifying it, you'll find that this one will become the root, that is it will come in this position, right? And hence we'll be getting the element which is a minimum. So we're going to use this concept over here. So what we'll be doing is that we'll be, let me just rub this up. So what we'll be doing, we'll have a min heap, okay, and let's say that there is a pointer and we'll be having a pointer. Let's say there is a pointer which is currently pointing to one of this linked list, and there is a pointer which is pointing to such there are, since the value of k is 3, so let's say that we have 3 pointers, right, which are currently pointing to each of the first element of this 3 linked list, okay. Now since there are 3 elements, since the value of k is 3, so the size of our min heap will be 3, okay. Now that is all. So thus we can say that the size of the min heap will always be equal to k, okay. That is, we can hold maximum k, maximum k number of elements into our heap, right? So in C++ we have a concept of priority queue, okay. Yeah, we have a data structure which is known as priority queue, and using this priority queue we can implement min heap, right? So what does this priority queue will do? So let's say that we have a queue, okay, and the size of the queue is actually 3, right, because the value of k is 3, okay. Now currently our pointer is at 1. There is the first pointer. This next pointer is at 1, and its next one is at 3, right? Now what this priority queue would do, the priority queue would implement our min heap. So in our queue, the front element will be, since we would be having, so we'll be pushing these three elements into our priority queue. Okay, so we're pushing 1, 1 and 3. Okay, and so so we can see that this one is the minimum one, right? And it is present in the topmost, yeah, and it is present in the front of queue, right? So what are we going to do, we need to have a, let's say we need to have a head, right? Now this head, is the head of our new linked list, right? Okay, now that is a sorted linked list which would be forming after merging these three linked lists, right? That is head. Now this is the minimum element, right? So our head will be currently pointing to this one. Okay, address of this one's address is currently pointing. Okay, you can say it. Okay, now now once we have now this one has come from this linked list, either of these two. Let's consider that this one belongs to this linked list, right? So when we have found that this one has belonged to this linked list, what do we do? We need to pop this one, and we would be incrementing this pointer to 2. So currently, and then we'll be pushing this 2 to our queue. So after pushing this to our queue, our queue would look like this. That is this one, since it is a minimum, so it will be come to the top, 2 in the middle, and then 3 will come, right? And now we can see again we have 1, right? Now we currently have our head, right, which is pointed to 1. Now we need this one, which is the head, right? You can see this is the head, right? We need this one to point to this one, right? So you can, over here you can say to point to this one, right? Okay, now once we have done that, now this pointer which is currently pointing to this one will be pointed to this 2. Okay, and hence in our queue we will be pushing 2, right? So let's push 2. So it will be like 2, 2 and 3. There will be 3 elements in this shorted fashion, and the top of the queue, and in the top of the queue contains the minimum element. So currently our minimum out of these 3 elements is 2, right? So we'll be pointing our ones next to 2. We can, since both of these two linked lists contain the same element 2 and 2, so we can either increment one of this. So let's increment this 2 to 4. Okay, again this 2 will be popped out, and we need to insert this 4, right? So let's insert 4 to the to our linked list, sorry, to our priority queue. So currently our priority queue would look like this. It will contain element 2, 3 and 4, right? Now current minimum element of this priority queue is of this min heap is actually 2. So we need to make our 2 points to this 2. Okay, and next this pointer will be moved over here, right? Now once it move over here, now again we need to pop this element, right? And our min heap will, and this 3 will be pushed into our min heap, right? So let's push this 3. So after pushing this 3, so our min heap will look like this, that it will contain 3 elements, 3, 3 and 4, right? Where 3 is the minimum element out of these 3 numbers. So we need to make this 2 point to this 3, right? Now again, now we can either increment this pointer or this pointer, right? Let's increment this pointer. So now our pointer will be pointing to this 5, right? And this 3 will be popped out, and we need to push this 5 into our queue, right? So let's push this queue. So 3, and then we'll be having 4, and then 5, right? So currently our minimum is 3. So again this 3 is gonna point to this 3, okay? And then we need to pop this out, right? Again, and then again we're gonna push this. Now we have popped this tree, right? Now once we pop this tree, now there is no more element for this linked list, right? So now this pointer will be pointed to null, right? Since there is no more element left, so the pointer will be pointing to null. So we'll not consider this pointer anymore, okay? So we only have these two elements, that is 4 and 5. So out of this 4 and 5, which one is the minimum? 4 is the minimum, right? So since 4 is the minimum, so we'll be just making this 3 points to this 4, right? So now 4 is popped, right? And this pointer will be incremented by 1, and hence it will be pointed to 6. Now we'll be pushing this 6 to our priority queue. So now our priority queue will look like this. It will contain two elements, 5 and 6, right? So now 5 will be the guy, right? Which is going, which would make this 4 points to 5, right? So once we make this 4 point to 5, now this 5 will be popped out, and since there is no more element name, now this pointer will be pointing to null, right? And we are left with only one element, that is 6, and hence we need to make this 5, next will be 6, and hence our linked list will be shorted, right? So time complexity for this algorithm will be big O of n. Now what is n? N is the total number of elements. So if you sum up the number of elements of this tree linked list, because currently the value of k is 3, and then that value would be our n, okay? And we need to multiply this with log of k. Now why log of k? Because over here we are taking a min heap, right? And in order to heapify a min heap, we're gonna perform log of n operation, and their the space complexity will be big of k, because maximum we can have k number of elements in our priority queue, right? And hence it is big of k. Now let's see the code for this algorithm. So the first line says that the list of size should be, if the list of size is equals to 0, then we have to return null. Now what does it mean? Now what does this mean? So let's say that we have a input which contains simply this, right? Which means that there is no list inside this vector, right? And hence we have to return null, right? Now then this is what we have done over here, and then we have taken a priority queue which of type list node, and we have taken two pairs, that is one is the int of integer type and one is of list node, right? And then we have actually min heapify it, right? Using the greater pair of, using this function we have created a min heap. Actually this is a min heap, okay? It is written as a priority queue, but this is actually a min heap, okay? This is how we write min heap in C++, okay? Now after creating a min heap, when we need to push the first element, so let's say that we have an input for like 1, 2, 3, right? And there is another input, and we have mainly two lists, right? So over here what we are doing, we are pushing the first elements of each of the linked list into our priority queue or min heap, okay? But it may happen that we have a input something like this. Okay, and that means the vector is not of size 0, right? But the list, but there is no linked list inside it, right? That means it is null, right? In such situation we need to check that also, right? And hence we have written this statement. And next we have considered a root, which is probably going to be the root of the final sorted and merged linked list, right? That is our answer. Now also we have taken a temporary pointer, and then we are checking whether our pq dot empty, whether our priority key is empty or not, right? And if our root equals to null, right, that means we need to, at first we need to have a get the head, right, of the linked list. That is our main task. So for that we have initialize our root to pq.top.second. That means which the element which is going to be minimum out of those, over here the minimum is 1, right? So we have point our root to this element. Okay, and then we have initialized our ptr to root, and if this condition is not satisfied, that is we have already got our head, right? In such situation we need to make our ptr of next is equals to pq dot top dot next. Here in this case, at first currently our head is 1, right? Now next we need to make this 1.22. That's what we are doing over here, and then we have to make our, currently our pointer is over here, right? So using this statement we are moving this pointer to 2. Okay, once we have done that, and then we are initializing our current address, right? So the current node, if you, yeah, so current node, and then we are popping that out. Now why we have written this statement? We have written this statement because let's say that we are at this pointer. Okay, now we know that 1 is the minimum, right? But next we need to move this pointer, that is a pointer which is currently at 1, we need to move this pointer to 2, right? And for this we need to we need to store the address of this as well as the element which is stored over here, and hence we have written this line. Next we are pushing the current of next dot val, and also that is a value as well as the address, that is we are pushing now 2, because we are done with 1, right? And hence we are pushing now 2. Now next we coming out of this loop, we are returning root. Now the time complexity for this algorithm will be, as I've already told you, is nlog k, because we are over here we can see that we are actually performing n number of steps over here, right? And once the elements are pushed, that is we can push maximum of k number of elements into our priority queue, right? And in order to heapify it, so we will be requiring log of k, and hence it is n log k. And since we are using a priority queue over here, as whose maximum size will be someone like k, and hence we have the space complexity is k. Now let's run this code. Okay, so let's run this code. Running this code, see, it is accepted. So I hope you like this video. If you like this video, do give a thumbs up to the video, share it with your friends, and subscribe to the channel and press the bell icon in order to get the latest notification first. So that's all for today. I will see you in my next video.